Hi everybody, today we're going to take a look at the maximum subarray question. This is question number 53 on Leetcode. It's in the category easy, and the question goes as follows. Given an integer array of numbers, find the contiguous subarray containing at least one number which has the largest sum and return its sum. Before we solve this question, let's go ahead and talk about what a contiguous subarray is. So I think we're all well aware that a subarray is basically an array which is composed of numbers from the original array. So for example, if I take the numbers -2, 1, and 4, then I would have a subarray from the original array. A contiguous subarray, on the other hand, has the additional requirement that the numbers in the subarray have to be in the same order as they are in the original array. So an example of a contiguous subarray would be the numbers -1, 2, 1, and -5, because the numbers are also in our original array and they're in the same order. But our original example of -2, 1, and 4 is not a contiguous subarray because we've skipped the -3. And so in this question, we're meant to find a contiguous subarray that sums up to the largest possible number. So how does that translate to our example over here on the right-hand side? The largest contiguous subarray of the array that we have over here are the numbers 4, -1, 2, and 1. Because if we sum them up, we get the number 6, and there's no other contiguous subarray which adds to a larger value larger than 6. And that is why the output of the example that we have over here on the left-hand side is equal to 6. So let's now think of an algorithm which could do the work for us. And we're going to start off with a brute force algorithm. And the way it's going to work is as follows. We're going to create an empty list. And this empty list is going to have the candidates of the output of the solution. And so what are we going to be putting into this list? We're going to be putting into this list, first off, the number -2. After we've done that, we want to add the 1 to it, and we're going to add the sum of the first two numbers to the candidates list. Then the sum of the first 3 numbers, then the first 4 numbers, then the first 5 numbers, and so on and so forth until we get to the very end. And once we've gotten to the very end, we're going to forget about the -2, and we're going to move on to the next number. So we're going to add -1, we're going to add 1 to the list, then the sum of the first 2 numbers, the sum of the first 3 numbers, and so on and so forth. And we're going to do this entire process until we get to the very end and add only the 4 to our list. And what's going to happen is we're going to have a list full of candidate solutions. But we will need to then sort these candidates in descending order and take the very first number from this sorted list, and we will have the output that we want. So in our algorithm, we're going to have 2 for loops. The first for loop is going to determine the starting number, and the next for loop is going to go through each of the remaining numbers and create the sums. So we're going to have this for loop, the first for loop, set the number -2, and the next for loop is then going to create the sum of the first 2 numbers. Then it's going to add the third number to this, which is -4. Then it's going to add the next number to this, which is going to make it 0. Then we're going to add the next one to it, and so on and so forth. So the second loop is going to be responsible for this process down here. Alright, so on the left-hand side in our editor, we're going to first define a function called algorithm, and we're going to pass in an array as a parameter. Subsequently, we're going to create a variable called subarray. We're going to set it equal to 0. And then we're going to create a candidates variable, and it's going to be equal to an empty list. After that, we're going to create our first for loop. So we're going to say for I in range length of numbers. and then we're going to set the subarray equal to the very first number in the numbers array. Once we've done that, we want to, of course, append these individual numbers from the original array to our candidates list. And then we're going to write the second for loop, which is over here the one responsible for creating the sums. And we're going to write for j in range I plus 1 to length numbers. And we're going to be adding the numbers with the index j to the subarray. And of course, we also want to add these numbers to our candidates list. Now, after we've done all of this, we have a nice list of candidates, but we need to do one more thing, which is we want this candidates list to be sorted, and we want it to be sorted in descending order. And now you can see if I return the very first element in the candidates list, I get exactly the answer that I wanted, which is 6. And I mean, we can try this for any other array of numbers. For example, if I take the array -2, 1, make this into a -4, and then put the last number to 5 and delete the remaining ones, and let it run again, you will see that I get the expected answer, which is 5. Now the time complexity of this algorithm is O of n squared because of this nested for loop. So let's go ahead and try another algorithm, and this time we're going to try and make it a little bit smarter and make the time complexity go down a little bit. Another way that we could solve this is to start off by picking out the number which is the largest, because we know that every contiguous subarray which is smaller than the largest number can already be excluded right off the bat. And another question that we need to ask ourselves is if we really need to compute the sum of each individual contiguous subarray. So if we're starting off at the -2 over here, and we add the 1, then we have a -1 in total. But the question is, why do we really start off with this -2? It doesn't help us. This -2 is no use to us at all. So we can already completely forget about this -2 and start from the 1. Now similarly, if we go ahead and add the -3 over here and get a result of -2 in total, then this result over here doesn't help us out either, because then when we add the 4 to this -2, we get 2 in total. But instead we could be starting off with a value of 4. So everything on this side makes no sense to be considered either. And so we need to apply this logic when we create the algorithm too. So let's go ahead and write the algorithm in the editor. We're going to define the algorithm and pass in the array nums. And subsequently, we're going to set the subarray equal to nums0. So it's going to be the first number in our array of numbers. After that, we're going to create a variable called max subarray, and it is simply going to be the max of the numbers, so the maximum number in the subarray, which is going to be the benchmark value. We already know right off the get-go that the maximum subarray is going to be at least 4 in this case. Then we're going to create a for loop, and we're going to say that for I in range and then the length of the numbers, and we're going to do this exclusion process that we just looked at on the right hand side. So we're going to say that if the subarray is smaller than 0, we're going to set the subarray equal to 0. And if that isn't the case, then we can simply go ahead and add the next number in our array to the subarray. And at the very end of this, we're going to compare the current subarray sum to the max number within the array which we defined earlier. And if the sum of the contiguous subarray exceeds the highest number in the subarray, then we have a new candidate. And once we've gone through all the numbers in the array, we can go ahead and return the max subarray. So now you will see that if I go ahead and print and execute the algorithm on the same numbers array that we had initially, you can see that the output is in fact 6. Now let's try and throw this algorithm off by making all the numbers in our input array negative. And you can see that it still works because it just chooses the highest number in the array to be the maximum subarray. And now the time complexity of this algorithm is O of n. So we have in fact improved our algorithm from the algorithm we had earlier, which had a time complexity of O of n squared. Alright guys, so I hope this video has helped you out. If it has, then remember to leave a like and subscribe to this channel, and see you in the next video.